Okay, so we are going to do our first segment proof. And what I would do is pause the video and copy the given and the proof and the columns, and then a nice neat diagram. Remember, proofs are very formal, very neat, and very organized. So go ahead and pause the video if you need to copy this down. Okay, so what I'm going to start off with, statement 1 is always the given. Okay, so I have DF is equal to EG. If you have more than one piece of given, I personally would prefer it if you use the given as you need it and not put it in all in statement 1, because you're going to be referencing those at different points or needing those pieces at different points. So I like to split up my given if I have more than one piece. So I have DF is equal to EG. Your first reason is always going to be given. Make sure that your numbers are across from each other. That's part of the formality of a proof. If I know that DF is equal to EG, DF, and because I can't put a tick mark because this is actually more than one segment, I'm going to put my pieces here. So DF is equal to EG. So what I'm noticing by that is the first thing I notice is that DF and EG, oh, my pencil pooped out, hold on a minute, that DF and EG have this overlap. Okay, so if you have an overlap, what's going to happen is you have this segment and you have this segment. So you're going to have to merge them together to get that overlap. And then what's going to happen is you're going to end up subtracting that overlap. Okay, so we're looking for that overlap. So I'm also noticing that DF is a whole segment made up of two individual pieces. So I am going to, 99% of the time, if you have segments, you're probably going to be using this segment addition postulate. So I am going to look at my whole piece of DF, and I know that DE plus EF equals DF because of the segment addition postulate. Okay, well, I have another segment, and that is EG. So EG, if you look, is also made up of two individual segments. So again, I'm going to go ahead and use my segment addition postulate. So I know that EF plus FG equals the whole segment of EG. Again, by this segment addition postulate. Now, you always have to think, why was I given the fact that DF is equal to EG? I'm going to look at this. I know that DF equals EG. Doesn't all of this equal DF? Doesn't all of this equal EG? So I can take and substitute and put all of that in for DF. And I can take all of this and substitute it in for EG. Again, about 99% of the time, if you have more than one segment in your diagram, you're probably going to use the segment addition, and then you're going to follow it with substitution. Remember, with substitution, we do not abbreviate it SUB because we also have the subtraction property. So I need to figure out, what do I get when I put this piece into here and this piece into here? So I end up with DE plus EF. That should equal EF plus FG. So let's see if we notice anything now. So I have merged them together. And like I said, usually with the overlap, you're probably going to end up minusing or subtracting something. Look, I have the segment EF on both sides. So if I subtract EF from both sides, I end up with DE equal to FG. And I can do this because of the subtraction property of equality. And I'm going to look, and the way that I know I'm done is that my last statement and my prove are identical. So that's how we know that it's done. You should never end up with a reason as being prove. That is not correct. Because I know I'm done, I like to put the 3 dots in a triangle, which means it's actually a recognized math symbol, meaning therefore, this is true. So that would be one example of using the segment addition postulate.